Hello everyone, welcome back to the channel. Sorry for the voice break. In today's channel, we'll be diving into one of the most important topic in machine learning, that is the bias variance trade-off. It's a part of deep learning also. That's why I'm covering it here. So just imagine that you are training a model to predict the house prices, and your model makes prediction. But what we want, that is it wrong and why it is wrong. So for that, we need three parts. First one is the bias. This is how far your model is from the average prediction and the actual truth. High bias means your model is making worth assumptions. It's too simple, it's underfitting. Second, variance. This is how much that your model prediction changes depending on which training data you gave it to. High variance means that your model is too sensitive, it memorizes noise and it's overfitting. Third, irreducible noise. It is just random noise in the data itself. No model, no matter how good it can fix this. This is just the reality but being messy. So your goal as an ML engineer is to minimize the bias and the variance, because you can't touch that the third one thing, okay, that the irreducible noise. Now, how does this looks in the deep learning? uh, Classical machine learning told us that the bias and the variance always trade off. See, like a seesaw, you push one down and the other goes up. But in the modern deep learning, this rule is being breaked. Think about it is in a regime, a small simple model, high bias, low variance at underfits. A perfectly sized model, balance. A very large model, classically low bias with a high variance, that is called as overfitting. But the crazy part is that the double descent, when you make your model massively over parameterized, many way more parameters than the training samples, sometimes the weird thing happen. The test goes up at first, hit the peak, and then goes down, and then again goes up. So this is the interpolation threshold. Deep learning achieved these through some of the something called as the implicit regularization. Okay, that how the training process has impacted like a regularization. Okay, now how you can control the bias and variance in this. So to be practical, how do you actually manage this? To reduce the bias, increase your model size, add more layers, more neurons into it, and give the model more capacity to learn. To reduce the variance, this is where regularization techniques come in. Dropout, during the training, you randomly turn off the neurons. Each forward pass is like training a slightly different neuron, and interference time is like an average of all these networks together, which naturally reduces the variance. Then we have the L2 weight decay. You add a penalty to your loss function, then pushes weight towards zero. Bigger lambda means smaller weights, which mean that the higher bias but the low variance. It's a knob you can turn off. Then we have the data augmentation. More diverse training data means that your model doesn't overfit to a specific pattern and reduce the variance. Then we have the batch normalization. This one is something special because it helps you with both bias and the variance. And the early stop also, that just don't stop training just before the model start memorizing the noise. Then we have transfer learning. Everything changes here. So transfer learning is something that we have quickly covered before only, so we'll not go into the depth for this. So all right, having a quick recap about things is that first, total equal error bias square plus variance plus irreducible noise. This is the only you need to know that only two of the things are in your control. Second, classical ML says that bias and variance trade off. Modern deep learning breaks them into a double descent. Third, regularization techniques like the dropout, weight decay, and the early stop reduces variance with only a tiny cost of bias. Fourth, pre-trained model give you a low bias and a low variance, especially powerful when data is scarce. Fifth, always monitor your data error as a proxy for the bias and train your validation gap as a proxy for variance. If both are low, then you are at a golden point. So that's for today. We have covered the bias and variance, and we have seen that how it is different from the bias and variance in the machine learning. In the machine learning portion, we have also covered in one of the lecture a small part of bias and variance, where we have seen that how small bias and large variance is different from large bias and small variance, how underfitting and overfitting can be done respectively. So these are some of the things that you have to keep in mind, that in deep learning part, it's not depending upon the particular range, and there is no particular sweet point. There are many features like the interpolation that we have discussed, about the regularization feature that we have discussed. So these are the things that you have to keep in mind while working with bias and variance in the deep learning portion. Thank you.